Okay, so this one is going to be about friction. First of all, you should understand friction is a type of force. The full name of friction is force of friction. We try to save like half a second to not say force of friction, but instead we say just friction. So if someone says there's friction, what they mean is there's frictional force. There are three things you should understand. There are only two types of friction: static and kinetic. Static when things are not moving, kinetic when things are moving, and these names will make more sense as we progress. Formulas for both of them is the same. They have the same form. It's something called coefficient of friction, and this symbol is called mu, mu, and this is the normal reaction that you know. You multiply the coefficient of friction, that is mu, by normal reaction to get the force. For kinetic friction, there is just one value of kinetic friction, and that is the normal reaction multiplied by the coefficient of kinetic friction, that is mu sub k, and that's it. But for static friction can be 0, and the maximum it can go is mu s times the normal reaction. So what I mean is that the minimum value of static friction can be 0, okay, and the maximum it can go to is fx max, which is equal to coefficient of static friction times the normal reaction. That is the first distinction that we have between kinetic friction and static friction. And one more thing, the friction is 0 unless there is motion or tendency of motion. So if there is neither motion or neither a tendency of motion, then there will be no friction. So the question, what kind of friction is useless, because there is no friction. There will be no friction if there is no tendency of motion or if there is no motion. So I've got this example here, and case by case we'll go through this example and see if we can answer a few questions about friction. So first one is, before that, let me give you a little context about this problem. You've got this not frictionless, I should say, surface. What that means is that this is not smooth, okay, and then there is a block of mass m, and whose weight or mg will be downwards. Normal reaction is the reaction force in the opposite direction. So that's that. We can also attach a coordinate system to it. Let's say this axis is x and this is y. Question 1 is, does friction exist, and if it does, what type? And this is a case of no applied force. So for example, there's no one pushing down here or down here. The friction is 0. I'm sorry, the applied force is 0. Okay. So does this friction exist? The answer is no, it does not. It does not exist because here we saw that the friction is 0 unless there is motion or tendency of motion. As you can see, since there is no force here or here, there is no tendency of motion, and since it is not moving, there is no motion, so there is no friction. What is the direction of friction? Well, this question doesn't really apply here, right? Because there is no friction. Will the block move? No, it will not move. And write down the second law of equation, Newton's second law equation. What that means is that we're trying to figure out these equations. If you add all the x component of the forces, that should be equal to mass times acceleration in x. If you add all the y components, that will be equal to mass times acceleration in y. So all the x component of the forces, right? So this means the x components, and there are only two forces we have. One is the normal reaction, the other is mg, and both of them are acting in the y direction. So they do not have any x components. That means in x direction there is no force. Okay, so this is pretty silly. It's just 0 equals 0 because it's not moving, so there is no acceleration in x, and because there are no forces, left hand side is also 0. But this guy, right hand side is 0 because there's no acceleration in the y direction, so it's not moving up or down, it's just sitting on the table. But we have got two forces, normal reaction and mg. Normal acting in the plus y direction, so I take it as plus n, and then mg as minus mg, so n equals to mg. So these equations are the equations of motion for the second law, or the second law equation. The next case, we have the same mass and block system, the mass and the table system, and this is again not smooth. but this time we have some force being applied, but the force is less than the maximum static force. Okay, like the maximum static force, right? So let's say there's a coefficient of friction here, mu s. The maximum static friction force is equal to the coefficient of friction times the normal reaction. Okay, so that is the maximum static friction. But let's say there's a force applied, and that force is capital F in this direction. Okay, so that is the scenario we have. The question is, does friction exist? The answer is yes, it does. And why the answer is yes? You go back to the third point here. The friction is zero unless there is motion or tendency of motion. In this case, there is a tendency of motion because there is a force in the plus x direction. Okay, because of this force right here, if this force gets big enough, this block is going to move. That is why there is a tendency of motion, and that's why the friction exists. What type? Answer is a static. Okay, it is a static because, you know, this is the thing with the static friction. It has a maximum value of mu s n. Okay, and it can supply the maximum it can supply is mu s n, but that is the maximum value. Okay, but if this force of friction is less than the maximum value, then the force of friction that is in the opposite direction, and I will tell you why that is true, static, applies the same amount of force that is being applied. Okay, this is true as long as the force applied is smaller than the maximum static friction. So if the force that is being applied is smaller than the maximum static friction, then the static friction value will be the force that is applied. It's going to match the force. So if the force applied is 1 Newton, so it's going to match up with 1 Newton. Let's make a little table here. Let's say this is force applied and this is static friction. And let's say the static friction max value that you calculated using mu s and m is 10 newtons. So if you apply 1 Newton, it's going to match up with 1 Newton. If you apply 2 Newton, it's going to match up with 2 Newton. It's going to go until you apply 10 Newtons here, and then it's going to apply 10 Newtons. But if you cross that, you apply more than 10 Newton, and then it can't apply 11 because the maximum it can do is 10. And we're going to see what happens in the later case. But the point is, if this force is less than the maximum value of static friction, then the static friction that will be actually present will be equal to the force applied. The next question is, what is the direction of motion? For the direction of motion, what you think of is, you look for where the motion will be if motion happens. So here we have got this force of friction here, this applied force here, right? So this applied force, if this force wins, the block is going to move to the right. Okay, so therefore the friction force will be on the left hand direction, on the left side, or on the minus x direction. That is the direction of frictional force. So it always opposes motion, or it always opposes tendency of motion. So direction of motion will be minus x direction because force is in plus x direction. Okay, will the block move? Well, let's see. If force, as we have learned, is smaller than the maximum force, which in this case we have, the frictional force is going to apply the same amount of force that is being externally applied. So that means that what we have right now is a situation where the force here is capital F, but here the frictional force is also capital F. That means that these two forces are balancing each other, and therefore the block is not going to move. See, for this block to move, one of these forces needs to win. Okay, therefore only then you will have a net force in either plus or x or minus x direction, and only then the block can move. The second law of the Newton's second law equation would be this. So f of y will not change. Summation of fy will be ma y, because it's not going to change, because in this case still we have just two forces, normal reaction and mg. So this is going to be plus n minus mg, and this is not moving in the y direction, so that is 0. So that's first equation. The second equation is this. Summation of all the x direction forces is equal to m times ax. So summation of all the x forces in the x direction is this. You've got plus f, because f is in the plus x direction, and minus fs, because this guy is in the minus x direction, and that is equal to 0. So that's your second equation for the Newton's second law. Alright, so this was the case when the force applied was smaller than the maximum static friction. Now what will happen if the force applied is greater than the maximum static friction? Okay, so question number 1 is, does friction exist? Of course it does. But you have to understand, for this case, the maximum, we made a little table where I had force applied here and frictional force here. So if the maximum it can do is 10 newtons, so until the external force reaches 10 newtons, the force of friction is going to match that external force every single time. But as soon as it gets more than 10 newton, let's say 11, the maximum it can do is just 10. Okay, so that means that there will be a net force in the plus x direction, because f is in this way and fs is in this way, but f is larger than fs. That means that there is a net force in the x direction. So the answer is, does the friction exist? Yes, it does, because there's for friction to exist, there should be two things. Either the tendency of motion should be present, or there should be motion. For in this case, there will be motion because there is a net force in the plus x direction. And what type of friction? This is a tricky one. Here the force of friction is greater than the maximum static force, and but because there is a motion, this is no more a static case, and therefore you have a kinetic friction here and not static. Remember, once the things start to move, you will not have static friction, but you will have kinetic friction. So that kinetic friction will of course be given by mu k, that is the coefficient of kinetic friction, times the normal reaction. And the direction of friction, well, the direction of friction always opposes the tendency of motion or the motion. So if the motion is to the right, because this guy f is greater than fs, that means that the kinetic friction is in the left direction. But remember, I mean, although it's greater than is greater than the static friction, the maximum value static friction, I'm not saying that there is static friction present. Because things are moving, the static friction is out of the picture, and the only friction that you have is kinetic. Will the block move? Well, of course it will, because we have a case where the force applied is being greater than the kinetic friction and static friction, and therefore the block will move. Think of this. This is always true. If this confuses you, this is something you should understand. The maximum value of static friction will always be smaller than the kinetic friction value. Okay, so because that is true, and I have not given you any proof, but I'm just telling you that is the case, that maximum value of static friction will always be smaller than the kinetic friction. Once your force is greater than this guy, it is going to be definitely greater than this guy. That means that if there's a force in the plus x direction, there's a block right here, and if that force is greater than fs max, then definitely there will be, first of all, a kinetic friction, and of course this will be true that the force applied will also be greater than fk, because fk is always smaller than fs max. I hope you understand this. So that is why the block will move. Writing Newton's second law the y direction equation is may, and again it's going to be just the same, plus n minus mg equals 0. But here there will be a change in x equation. And in x equation, you've got this force in the plus x direction, so you write it as plus f. And because you have kinetic friction and not static friction, you write f sub k equals max. This time, right hand side is not equal to 0 because things are moving. Okay, so there's some acceleration. So now you can plug in fk value if you want, and that's going to be mu k times normal reaction, and that is going to be max. Let's say we want to figure out what is the acceleration. You write ax equals, divide both sides by m, so you get mu k n divided by m, and that is the answer for acceleration in the x direction. So here we saw, first of all, we started with these 3 points to understand basic things about friction. Then we saw this case, and this context of this mass being on a table which is not smooth, and we saw these cases. First was there was no force applied, and we tried to answer a few questions about that. And then the second case was the force is applied, but it is less than the maximum value of static friction, and we answered a few questions. And we saw this, the very last case, force applied was more than the static friction, and then we answered a few questions. And we also figured out what will be the acceleration, because this will be the case where the block will move.